Hello class. In this lecture, we will learn the working of a thyristor using the two transistor analogy. The principle of operation of a thyristor can be explained by the two transistor analogy. Figure on the left shows the schematic diagram of a thyristor. A two transistor model is obtained by bisecting the two inner layers into two halves. Junction J1 J2 and J2 J3 can be considered to constitute two separate PNP and NPN transistors respectively. The two transistor model is thus shown on the right. For a transistor in the off state, the collector current IC is related to emitter current by equation IC is equal to alpha IE plus ICBO, where alpha is the common base current gain and ICBO is the common base leakage current of collector base junction of a transistor. For transistor Q1, as shown over here in the figure, the emitter current IE is the same as the anode current IA. The collector current IC for transistor Q1 is IC1. The collector current IC1 is given by IC1 is equal to alpha 1 IE. Here the emitter current is the anode current. So we will write it as IC1 is equal to alpha 1 IA plus ICBO1, where alpha 1 is the common base current gain of transistor Q1. ICBO1 is the common base leakage current of Q1. Similarly, for transistor Q2, IC2 is equal to alpha 2 IK plus ICBO2, where IK is the emitter current for transistor Q2. Alpha 2 is the common base current gain of Q2. ICBO2 is the common base leakage current of Q2, and IK is the emitter current of Q2. If we look at this transistor junction over here, the external circuit current IA is the sum of the two collector currents IC1 and IC2. So IA is equal to IC1 plus IC2. The same is written over here. If we substitute the value for IC1 from equation 1 and IC2 from equation 2, we will have IA is equal to alpha 1 IA plus ICBO1 plus alpha 2 IK plus ICBO2. When gate current is applied, the cathode current is the sum of anode current plus gate current. If we substitute the value of cathode current IA plus IG in above equation, we will get IA is equal to alpha 1 IA plus ICBO1 plus alpha 2 into, I have replaced over here IK equal to IA plus IG. So alpha 2 into IA plus IG plus ICBO2. After expanding this equation and bringing the terms involving IA together, we will have this equation. Rearranging the left side of the equation, we will have IA into 1 minus alpha 1 plus alpha 2 is equal to alpha 2 IG plus ICBO1 plus ICBO2 Again, rearranging this equation to get an equation for anode current IA, we have anode current IA equal to alpha 2 Ig plus ICBO1 plus ICBO2 divided by 1 minus alpha 1 plus alpha 2. If we observe this equation, we will find out that if somehow alpha 1 plus alpha 2 approaches unity, the denominator will be 0 and the equation for IA will tend to infinity. Figure shows the typical variation of current gain with emitter current of a thyristor. As shown in this graph, for low emitter currents, the value of alpha is small. But as the value of emitter current increases, the value of current gain alpha increases rapidly. For a thyristor forward biased, that is anode positive with respect to cathode, and zero gate current, the value of emitter currents is very low, and hence the values for alpha 1 and alpha 2 is very low, and the anode current will be somewhat greater than ICBO1 plus ICBO2. However, somehow, if we are able to increase the emitter current of either of the transistors and thus increasing the value of alpha such that alpha 1 plus alpha 2 approaches unity, then as per this equation, the value of IA will tend to infinity. Thus, the device will turn on. In two transistor analogy, we had learned two important conclusions. With the anode positive with respect to cathode and zero gate current, the anode current is very less and somewhat greater than ICBO1 plus ICBO2. In order for the thyristor to turn on, we had learned that somehow the values of alpha 1 plus alpha 2 should increase and the sum of alpha 1 plus alpha 2 should reach unity in order for the thyristor to turn on. Let us consider that the thyristor is forward biased, that is anode is positive with respect to cathode, and a gate signal that is sufficient to turn on the thyristor is given to the thyristor. On the application of a gate signal, there is existence of a base current for transistor Q2. Because of this base current, the base emitter junction is forward biased. The emitter current IK is equal to the gate current IG. Because of the existence of the emitter current IK, there is an increase in the value for alpha 2. Because of the existence of the gate current IG, there is existence of collector current which is given by the equation IC equal to beta IB. Therefore, IC2 is equal to beta 2 IG. This collector current also acts like the base current for transistor Q1. Since there is a base current for transistor Q1, there is an existence of collector current IC1. IC is equal to beta IB. Therefore, IC1 is equal to beta 1 times the value of IB. The value of IB now is beta 2 IG. Therefore, IC1 is equal to beta 1 beta 2 IG. For transistor Q1, since IC is present and IB is present, there is existence for an emitter current IE. Since there is an emitter current present, the value of alpha increases. With the new value of IC, the new value of IB for transistor Q2 increases. Therefore, new value of IB for transistor Q2 is IG plus beta 1 beta 2 IG. In simplified form, we can write it as Ig into 1 plus beta 1 beta 2. Since the value of Ig has increased, the value of emitter current also increases. Therefore, IE, that is Ik, is equal to Ig into 1 plus beta 1 beta 2. Since there is a presence of gate current, there should be an existence of a new collector current. Therefore, the new value for collector current is given by beta 2 times the new value for base current. Therefore, IC2 is equal to beta 2 times Ig into 1 plus beta 1 beta 2. The same collector current acts like the base current for Q1, and hence the value for IC1 will also increase. Since the value of IC1 will increase, the value of IA should also increase. Thus, increase in emitter current of both the transistors results in the increase of values for alpha 1 and alpha 2. At some point, the value for alpha 1 plus alpha 2 will reach unity and the thyristor will turn on. Thus, there is a regenerative action occurring in the thyristor. The regenerative or positive feedback effect causes alpha 1 plus alpha 2 to grow towards unity. As a consequence, anode current begins to grow towards a larger value limited only by load impedance external to the device. When regeneration has grown sufficiently, gate current can be withdrawn. Even after gate current is removed, regeneration continues. This characteristic of the thyristor makes it suitable for pulse triggering.